Dum, 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 dum. Hello. So what are we doing today? Offline, I did some improvements on the code. Let me show you that. So I have to wrap up these projects. And let me show you what I have done. Dun, 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 dun. So before, as you know here, this is our data set without any changes, raw data. All columns are strings. So before I renamed column names, and then I added the days column, and then I added days here using this loop and changed strings to float numbers. I made a search on the internet to see how this getting days from the dates are properly done. And I found a Python package called datetime, calendar, and dateutil parser. So what these do is you get the string date and then apply a lambda function on it to actually change the string dates with their actual how can I say, this essentially converts strings to strings of dates to time, to actual numbers. But this has to be done. This is not a simple string conversion. So here, our dates, let me also show you the links. So these are the links that I utilized. So here, this is our date format, July 18, comma, slash, space 2021. So if you get so this is the first entry. This is a string, okay? And I told you about the format. So if you scroll down on this page, there are some sample, there's that. Is it not this document? No, it's not this one. Let me be sure. I had so many tabs open. Hide zoom floating menu control. I will find it. I will find it for you. Oh, this is that one. This is also that one. Anyways, okay, I will find it later. But the thing is, so what this does is it gets the date column, works on the date column specifically, and it applies this lambda function, which is you get the data frame. On a data frame, you call this function datetime, and then its method string parse time, and you give the input, which is this whole column, but this works, you know, element by element, and you give it the actual format. So mine is, you have to use the percent signs. Mine is, so this is, for some reason, is represented by B, small b, so month. I actually want to find this document. Date, time. Okay, this is awesome. This is awesome. So in this table, you will find what is your what signs you should use. So if it's months locale full name, you use percent capital B. If it's abbreviated form, you use percent small b. So you enter the format of your date time string, and you see what this does. So actually, let's see, I have never ran this. So as you see, this converts it to actual date format. And if we, so it's already converted, but check the type. So now it's timestamp. Okay. And then what this does is this creates a day column using the date. This creates a day column using the date column values, and it gets what day of week it is. But this will return a numerical value. Like if it's Friday, it's 5. If it's Monday, it's 1. And then you apply another lambda function using the calendar package, and you get the day name. Okay, so this will actually generate the string of the name of the day. So what I do here is, so this column is added to the end. I pop that, but I keep the data in day call, which is day column, the abbreviation, and I insert that. Let's delete this, and I insert that after the date. And that's the result. So I don't need this anymore. And we can continue with changing column names and changing the type of the price data. And here, what day of the week? So we need actual weeks. And let's see, can we get the weeks similar with the similar approach as we did for the day? Boom, 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 boom. So to do that, by the way, I missed to say that. So DT is the alias for the library. In that, you still have to call date time again, and then its method string parse time. So let's see if this works. Okay, you see, there's day name. Okay, month name. You will need that. There's probably something called week name. So we can try using that. Should we call this? 0 to 6. Sorry, no. Oh. And okay, maybe. And then we put the week here. But the problem is, before I was doing week is from 1 to, I don't know, 500 something. So if I have week from 1 to 52, so before I was doing 1 to 52, and then this gets a subset of data set, and then group by week. So if I group by using that, then this will be like, there will be, if it's for 10, if the data is 10 years old, or if data has 10 years of price history, it's going to be like, there will be many ones. There will be 10 week 1. So that's not what we want. This, and this, and then So if you want to make this analysis for a month, like what is the best time of the month? So do I need does all this work? There's probably a lot better way, but maybe I'm not going to learn it today. Yeah, I feel like this slows me down. So what I'm gonna do, I'm going to um, just, you know, so, okay, what is the goal of today? Today's goal is run the chi-square test and visualize. So visualize, so do this for um, best day of week. Okay, that's the goal. Let's start and worry about the rest later. Okay, this gives us something. Okay. And we can also get this. here. So we don't need this anymore. Let's keep it for now. Rename and convert, good. Now let's add the weeks. And then this is the tail. Exclude some of the weeks. So we exclude weeks after 37. And we assign it to another data set. This is how we did it. We excluded 37 weeks. Created the subset. Now what this does do is gets the days. So this is the days data set. So we are days series. Days equals subset dot group by, we group by week, and this is actually unnecessary. And we apply a data lambda function, which is in that data frame. We get the location that the price is minimum for the given week, and get that column and just the day column from the data set. Get that row and then get the date column. That's the days column. And then this is our histogram. What is this? This is number of minimum weekly So now we have to run a chi-square test.
In case you missed it, Kohl's home sale is going on now. Get up to 20% off Shark vacuums, up to 20% off Ninja appliances, save on Ninja cookware.
Hello, everyone. In this lesson, the 5 and having a two-tailed situation, and then saying the more they are actually different. Now, we went through the trouble of calculating the chi-squared statistic and p-value by hand, but of course in Python you can load in packages that will run functions that can do a lot of this stuff for you pretty much automatically without having to do that sort of thing. So instead of doing all the steps we did, we could have instead used the SciPy stats function chi-square to do the same thing. I'll show how to do that below. We just want to call stats.chi-square. Then the first argument, fobs, is going to be our observed counts, and then the fx is going to be our expected counts. We've already saved these, so we can just pass those right in. And when we run this, we'll do the chi-square goodness of fit test, and we'll basically get the same results that we did manually, but now it's just done in an easier way. So you can see the resulting information here. We got the same test statistic, that's this first one.
Okay, so one problem is, so I looked at this offline. Where did I add this? Okay, so this is the expected series that we are going to feed into the chi-square test. But the problem is, oh, I remember now. I deleted that column. Can I bring that back? That's okay. The new cell. Paste the part of the code that got deleted, and don't forget to paste. This is from a problem set. Pressing escape key. This is worse. Okay, now we have Let's save this first. So we have expected. What I deleted was the observed set. So we need observed. And we have to do the same thing. I'm not too worried because so what we're gonna do is so okay. So the subset group by week, apply a lambda function to that, get the day column. So what I'm doing, wait. Observed. Group by week, find the minimum, what days it is, and then gets the day column. Okay. And then the group by day. So basically, maybe I find in the previous version. Okay, let's see what I did here. Okay, same thing. And then I group by day, count, and then I get the date column. Okay, that wasn't too far. I didn't get the date column. But this is my observed data. This is my expected data. Let's try this. Stats.chi-square. Do I have what package this is? scipy.stats. Stats. Which one comes first? F observed, F expected. Voila. So what this means? This means that, so look at our p-value. So generally p-value, this is different, okay? This is different for every data set, every field of science, but generally the convention is if p-value is less than 0.05, which means if the observed behavior, in this case, the price behavior, is statistically significant, and this, the chance that this is false is less than 5%. In this case, the observed p-value is crazy low. So it means that if someone would buy Bitcoin every week on Mondays, there's a good amount of chance that they catch the lowest price during the week. That's one thing. Interesting. So chi-square test basically looks at the divergence. So you have the mean, the expected values. What we did here is basically when we ran this test, if the null hypothesis is you don't expect any day of week has an advantage to any other day of week. So if you have 536 weeks, the expected distribution should be roughly 77 weeks, 77, roughly the price would be equally low or high at any day of the week. So basically, the minimum price is over 536 weeks coincided equally to one of these days. And we would see this graph around like each column as high as like roughly like 77. However, this is what we observe. And this test basically looks at, okay, how different the Friday value. By the way, my test might be wrong, okay? It might be wrong. And I'll come to that because I think I forgot to do something. And I'll tell you the reason. Maybe you already realized. But okay, what this test does is it looks at the difference between the expected and the observed value. It gets the square of it to get rid of the negative values. And then divides it by, it gets the sum of the chi-squared value. It calculates the chi-squared value, I guess, observed minus expected squared divided by expected. So it looks at how much does this diverge from the expected value. Gets kind of a pseudo ratio. I say pseudo because the top is squared, the numerator is squared, so it's not actually the ratio. It was absolute value, maybe it would be, but then anyways, it calculates a chi-squared value. So, and when you do this by hand, you have to go what you do is So let's say you're looking for the case that the chance that our analysis has less than 5% chance that it is false. So you'll look at this column for p-value less p-value 0.05, and then your degree of freedom is simply we have 7 days of a week. So there are 7 outcomes of our observation, and then you do 7 minus 1, which makes 6. So you come here, look at this column, and then find the chi-square distribution, chi-square value corresponding to that. If your value is larger than this chi-square value, it means that your analysis, your results are statistically significant. Sorry. So this is what basically this command does. It does it for you. So this is, I think, our chi-squared, and this is our corresponding p-value incorporating df. The reason I said this is probably wrong because the order of my data is wrong. So this is alphabetical order. This is the actual order of days. Actually, just for ease, what we can do is with my internet again. Sorry guys, sorry for waiting you. Okay, didn't change. Interesting. But now if you see, the order of my both data sets are the same. So yes, so this shows that Mondays are statistically significantly cheaper. What we can do, here are some ideas. We can do that to see if a week of a month, we can check whether if a week of a month is particularly cheaper. We can check a month of a year, if it's particularly cheaper. We can check if a week of a year is particularly cheaper. We can check if a day of a year is particularly cheaper. So we can do all sorts of things. And we can do that actually, I can do that, but not today. So for today, that's all. Save it. And I guess that is it.